Hi everyone, this is Mr. Arsal, your Ontario Math Specialist. So welcome to MCV4U Calculus and Vectors. Now in this course, we are going to build a very deep understanding of calculus and vectors step by step, but this is lesson 1.1. So in today's lesson, we're going to be starting with the foundation, right? So we're going to start with reviewing key functions, concepts, and introducing something very important, that is rates of change, right? Now, make sure you stay till the end because this concept is the basis of all the calculus that you're going to be learning. So let's have a quick review about what are functions first, Okay. Now, let's say if I have something like this. F of x equals to x squared. All right. Now, this is a function. Why? Because again, you're like, hey, this is f of x, this is a function. Hey, you know what? Function is basically, now a function takes an input and gives exactly one output. Okay. Let's say, for example, if I give the function an input of x equals to 1, this particular function, right? F of x equals to x squared. Now, this is a function. I say that, hey, x is equals to 1. So let's try this out. So let's say f of, now this would be f, and then the x value I'm giving is 1. Let's make it a little more interesting. Let's say this is 2, So f of 2 would equal to 2 squared. So the value of f of 2 will give me one single output, that is 4. 2 squared is 4. Another example, let's take another example right here. Let's say f of x equals to 2x plus 1. Now, this is a line. This is a linear function because the highest degree is just 1, right? And I say that I'm going to find out the value of, or what is f of 3. Okay. So in this case, I will plug in the value 3 into x. That is my input. 2 times 3 plus 1. Now, this is very simple. 2 times 3 is 6. 6 plus 1 is 7. It gives me a value of 7. Now, what I want you to do is let's quickly try some of these questions that you're going to see on the right. Okay, so let's say, what is f of 5 if f of x equals to x squared plus 1? Now, I want you to pause this video and try this question right now, and let's see how well you perform. Okay, we're going to go with the answer now. So f of 5 equals to 5 squared plus 1. 5 squared is 25 plus 1, which gives me the value 26. So the value of f of 5 equals to 26. So when I plug in the value 5 into x, I get the y value 26. So far, so good. Now, this was what we needed to know about functions before we get started with calculus in detail. The next part that we're going to talk about is rate of change, right? But before we talk about this, we need to understand a little bit about graphs. So let's have a look at the graphs. Let's say we have a parabola. Okay, let's say we have a parabola right here. Now, this graph will endlessly stretch in both directions. So it will endlessly go towards infinity in both directions, right? And then we talk about coordinates, right? So this is the x-axis. Remember this. This is the x-axis. This is the f of x, or sometimes we call this as the y-axis as well. And whatever input that is here, for example, if this value here is 2, for instance, right? This value here is 2, right? And the other value here on the other direction would be 0. All right? You can use some dotted strokes to observe this. Now, if I take another value, let's say 3, and the y value here, or the f of x value here, it could be something like 9. Now, what we call, or we together consider this point as a coordinate. We call this as a coordinate, and we write down the x coordinate first, and then we write down the y coordinate. So this coordinate will be 3, 9. And similarly, this coordinate will be 2, 0. X coordinate first, y coordinate second. Now keep this knowledge at the back of your head because we want to understand graphs. And graphs are going to be really helpful when we continue this. Okay. Now let's introduce ourselves to rate of change. Now see, we have two different types of rates of change, average rate of change and instantaneous rate of change. But hey, what is rates of change? What is a rate of change? Now let's say, let's say we have you right here. This is your car. You've been driving. Pretty sure you guys have started to get your driver's license. And this is your car. You're driving, you're driving and assuming, hypothetically saying that your car is traveling at a speed of, or no, we're not going to talk about speed. Your car is traveling 100 kilometers. Let's say, you're traveling 100 kilometers within GTA, right? And it takes you 2 hours. Now, the question is, hey, I know the distance. I know the time. What will be my speed? What's my speed? Big question. Well, hey, we've been learning this in grade 6, 7, no, not in grade 6, but like 8 and 9, that how you calculate speed. Hmm. So let's see, let's have a look here. Speed is essentially distance over time, so 100 kilometers over time, the distance over time, which is you're approximately traveling at a speed of 50 kilometers an hour. That is the rate of change, right? How fast is something, or how fast is something changing? That is rate of change. So you're moving at a speed of 50 kilometers per hour. So let's say if this was this road, you are changing this fast, from one point to another point, so on and so forth. Your speed is 50 kilometers an hour. Now, this is rate of change. Now, the average rate of change it's a different concept, and instantaneous rate of change, it's a different concept. They're all similar, of course, but they're different. Now, in this lesson, we're not going to be focusing on instantaneous rate of change. We're only going to be focusing on average rate of change. Okay, let's say I have a function, f of x equals to x squared. Let's take an easy function. And the question goes on, and they're like, hey, you know what? Find me, or find rate of change from x equals to 1 to x equals to 3. Now, first of all, we're going to discuss about this box that we have here. Hey, we have a box here. There's something inside the box. We have the formula. Average rate of change. We have the formula. No one's interested. No one wants to know about the formula. I gotta memorize it. Yeah, we're gonna get through this part, And let's see. It's f of b minus f of a over b minus a. This is the average rate of change formula. Now, what is b? What is a? We don't know. B and a is given in the question. The input value 1 and the input value 2, 1 and 3. That's given in the question, right? So we know about the values a and values b, right? We want to find out what will be f of, let's take a as a equals to 1 and b equals to 3. So f of b would be f of 3. F of 3, according to the equation there, would be 3 squared, which is equals to 9. Now I know the value there. Let's take f of 1, a. This is 1 squared, which stays as 1. Okay, I'm halfway there. So I know the values of a and b. I know the f of a and f of b. You know, this is essentially f of a. This is essentially f of b. F of a, f of b. Now we just plug it directly in, right? So f of b is 9 minus f of a is 1 over b is 3 and a is 1. Now this is 9 minus 1, 8, and 3 minus 1 is 2. I can simplify this further. This would be 2 times 1 is 2, 2 times 4 is 8. So the rate of change is 4. The average rate of change is 4. This means I can say that the function is increasing at an average rate of 4. Yep. Now this is what average rate of change is. Now you might be looking at some other formulas in your textbooks and you're like, hey, I see a very different formula there. I see this formula. It's something very weird. You know, limit change t 0 s over st limit h 0 s over a plus h. Oh, wait, this is the wrong formula. Don't look at this. Don't look at this. Wait. This is the one that you might find in your textbook for average rate of change. Yeah, you might find this equals to f of a plus b minus f of a over b. Okay, let's make it a little different. Sometimes you might see an h instead of b. That's okay. Same thing. Now, apparently, I feel like this is a more complicated formula for the kids, you know, for the students. Um, they tend to like, you know, find this more difficult, but this is the same thing. You can say this is an expanded version of this formula, right? This is an expanded version of this formula. So you don't need to worry. You can use any of these formulas and you'll get the same answer. So, yeah. Okay. Next up, we're gonna talk about a graph. This graph right here. Back to the graph, you know, back to the graph. So we're gonna do one thing is we're gonna grab a ruler and let's draw a secant line. So secant line is a line that connects 2 points on a curve. A straight line that connects 2 points on a curve. Let's use a green line. Now this is a secant line that I have here. Now it looks or it closely touches the 2 points on the curve, but sadly, it's not exactly like the curve, but if we see this part really close, it's very close to the curve, very similar to the curve. Now, this line essentially represents the average rate of change between 2 points, right? So we are trying to find out the average rate by which the points are increasing from this point on to this point on, right here, using this line. This is what average rate of change is in practicality, or if you want to visualize this is how it looks like, right? So essentially, this is what we're doing. Now, so far, any questions? If you don't have any questions, leave them in the comment section, and I'm going to try to answer them. Okay. Let's start some guided practice questions. So on the graph, this is how it looks like. We use a secant line. We use a secant line to measure average rate of change. Generally, we utilize these formulas. I prefer this formula. It's the same thing as the formula that you'll find in your textbooks if you're going through the Nelson textbook. But yeah, I find this more simple and more straightforward. Practice questions. If you look at the practice questions, let's say let's start with the first practice question. Let's say we want to find out. Now, I'm not going to write down average rate of change again and again because, hey, who wants to write that much down? So let's say AROC, the short form of average rate of change. You want to find out the average rate of change for a function. The function given is 2x squared, and we have two different values from which we want to find out the average rate of change, from x equals to 1 to x equals to 4. Okay, now before I go ahead, I want to show this on the graph as well. So we will go and write down the function and graph the function. Let's take a quick picture of the graph as well, 2x squared. This is how the function looks like. Yeah, yep, much better. Now let's take a quick screenshot of this. Okay. So we have it right here. Now observe this, oh, wait, we cannot see 4 because we need the value 4 there. Yep, much better. Let's take another screenshot. Let's bring it back to OneNote. Yep, we have it here. Yeah, let's observe this. Let's observe this on the graph. Now, on the graph, this is the value 1 right here. This is the value 1, and this is the value 4. Right? So at 1, this is where we are at, and at 4, this is where we're at. Let's find out the y values as well for the sake of understanding. At 1, this is at y value 2, and at 4, the y value is 32. Right, so at 4, we get a y value of 32. This is essentially 32. I might just go ahead and use a smaller thickness marker. 32 right here. And here, the value was 2. So this is 2. Great. Now what we're going to do is we're going to draw a secant line connecting these 2 points. This is a secant line connecting the point that is 1 right here and the other point that is 4. Okay. Now, once we draw the secant line, what we are going to do is we're practically finding out the change, right? Or you can consider we're just trying to find out the speed in a manner, right? If this was a route, this would be a speed, straight line, straight line. You want to find out the rate by which it's changing. Now, this is average rate of change. We're going to utilize the formula. What was the formula again? What was the formula again? Well, hey, the formula is right here. We're going to grab this box again and keep it on the side. This is the formula right here. Okay. Now what we're going to do is we will assign values. Let's say A equals to 1, B equals to 4. And yeah, we want to find out f of A. We want to find out f of B. Let's go. So f of A would be, well, we just did using the graph right now, or you can mathematically find it out. I'm just going to continue this and we're going to mathematically find this out as well. 2 times 1 squared, which is 2. So we get the value 2 right here if you observe. And similarly, this will be 2 times 4 squared, which is 16. 2 times 16, which is 32. And that's how we get the 32 right here. Yep. So what we're going to do essentially now is just f of b minus f of a. F of b is 32 minus f of a, AROC, equals to 32 minus f of a is 2 over b, which is 4, minus 1 is minus a, which is 1. So 32 minus 2 is 30, and 4 minus 1 is 3. Now we know this is, you guys can plug this into the calculator, but 3 times 1 is 3, and 3 times 10 is 30. So the average rate of change that we have here is 30. Any questions? Okay. Let's try another question. Let's say we have f of x equals to 3x plus 5. Now I'm going to try this without any graphing. From x values equals to 2 to x values equals to 6, right? So what we're going to do first is assign a value. A equals to 2, b equals to 6. Assign values a and b. I'm going to go with the blue. And then we find out f of a, which equals to f of 2, which equals to 3 times 2 plus 5, which equals to 3 2s are 6. 6 plus 5 is 11. Then we know that the value of f of 2 is 11. Then we find f of b, which is f of 6, which equals to 3 times 6 plus 5. So 3 times 6 is 18. 18 plus 5 is 23. 18, 19, 20, 21, 22, 23, 20. Yeah, sorry, 23, right? 23, you get 23 there. So this is basically 18 plus 5, which equals to 23. Now, you know the values, you know two values, you know that f of a equals to 11. You also know that f of b equals to 23. Now, what you're going to do next is we just simply plug it into the formula. So AROC equals to f of b, 23, minus f of a, 11, over b minus a. B is 6, minus a is 2. Now you guys can directly plug this into the calculator. If you want to solve this manually, you can go ahead and we can try that as well. 23 minus 11 is 12, and 6 minus 2 is 4. And you get an average rate of change of 3. Now you don't really need the graphs, but if you want to visualize, you guys can plug this on Desmos and draw a straight line. And you can do questions completely by using graphs, by finding the f of x values, and then plugging it in using the graph, or you guys can do it without the use of graph, just mathematically. Okay, Now we have a couple of questions for practice. You're going to practice some questions yourself, and then we're going to discuss the answers. I'm writing down the questions here. You can pause the video, take as long as you want, and try these questions. Zero to x equals to 2, f of x equals to 4x minus 2 from the values of x equals to 1 to x equals to 5, and f of x equals to x squared plus 3x from x equals to 1 to x equals to 3. The question says, oh wait, I'm going to write down part 1, 2, and 3. Question goes on, says find average rate of change for the following. Okay, that's your chance. Try these questions out. You can pause the video, and I'm going to be discussing the answers in a couple of seconds. So yeah. Okay, now it's time for the answers. Welcome back. Welcome back. Let's talk about the answers. Let's look at the first part of this question. Which says we want to find out from the values of x equals to 0 to the values of x equals to 2. Okay, now we will give a and b values. So let's say again, I'm going to paste the formula back here so no one forgets it. Memorize this formula, guys. Memorize this well. This is going to come very handy. Okay. So A values, let's go with 0. B, let's go with 2. Now, remember, you're going to give the larger value as B and the smaller value as 0. Well, it practically doesn't matter, but I personally prefer having larger values to be B and smaller values to be 0. I mean, less smaller values to be A. But it's up to you. You can write it down in any order. You will still get the right answer. It doesn't really matter. So, and then you want to find out f of a, which is equals to f of 0, which is equals to 0 squared plus 1, which is equals to 1. So we know that f of a equals to 1. Similarly, we will find out f of b, which is equals to f of 2, which equals to 2 squared plus 1, which equals to 2 squared is 4, 4 plus 1 is 5. So we know that f of b equals to 5. Eventually, we will just do f of b minus f of a, 5 minus 1 over 2 minus 0. This will give me the average rate of change, which is equals to 4 over 2 minus 0 is 2. 2 times 1 is 2. 2 times 2 is 4. So the average rate of change is 2. Any questions? Let's go on to the next part of the question, right? This is the question. Let me quickly grab the question. Let's write it down here. Okay, let's look at the answer now. So again, this is also very simple. We will follow the same process again. So we will give values a and b. Let's say a equals to 1, b equals to 5. And let's continue. So first you'll find f of a, which equals to f of 1, which equals to 4 times 1 plus 2, which is 4 times 1 is 4, 4 plus 2 is 6. So f of 1 equals to 6. So essentially, we now know that the value of f of a equals to 6. Similarly, let's find f of b, which is equals to f of 5, which equals to 4 times 5 minus 2. Hey, this is minus 2. So this will be 4 minus 2, which is 2, not 6. Okay, this gives me 4 times 5, which is 20. 20 minus 2 is 18. So f of b equals to 18. Okay, great. Now we know everything. We will subtract f of b according to the formula with f of a. So f of b minus f of a over 1 minus 5. 1 minus 5. No, we're not gonna do that. We're gonna take b minus a. So it's gonna be 5 minus 1. A lot of students are like, hey, you know what? We're gonna do 1 minus 5, but don't make this mistake. So average rate of change equals to this. Right here, 18 minus 2 is 16. 5 minus 1 is 4, which is equals to 4. So this is our average rate of change for question number 2 in practice questions. Let's have a look at this question. Okay. This one's similar, very similar question. Let's try this out. All right, let's go. So first we'll give values a equals to 1, b equals to 3, find f of a. Now if I want to find f of a, this will be f of 1, which equals to 1 squared plus 3 times 1, which is 1 plus 3, which is 4. So we know that f of a equals to 4. Similarly, f of b equals to f of 3, which equals to 3 squared plus 3 times 3, which equals to 9 plus 9, which equals to 18. So we now know that f of b equals to 18. Now what we're going to do is we're going to take f of b, subtract it with f of a. So average rate of change will be average rate of change equals to 18 minus 4. Divide that by b minus a. Remember, b minus a, 3 minus 1, which equals to 7, right? So 18 minus 4 is 14, and 14 and 3 minus 1 is 2. That is 7. So the average rate of change here is 7. Okay, so with this, we have successfully learned what functions are. We just did a quick functions review right here. Then we also talked about rates of change, right? So we talked about the 2 different types. Now, of course, I didn't really go over this topic, instantaneous rate of change. For this, you can look at my next video. We talked about secant lines. Secant lines are lines connecting 2 different points on a curve, right? It's a straight line, right? We talked about average rate of change and the formula that's utilized. Again, secant line right here. So yeah, all in all, we have talked about a couple of things. Number 1 is, hey, functions. What are functions? That's done. What is rate of change? Then we talked about average rate of change, and we talked about secant lines. So I post, lectures every single week. And if you want to stay up to date, make sure to click that subscribe button down below and click on the bell icon as well so you get notifications for whenever I upload a new video. So yeah, in the next lesson, we're going to be talking about something even more powerful, instantaneous rate of change. Okay. Thank you so much for joining in the lesson. And yeah, make sure to subscribe if you want full MCV4U courses step by step.